Hi guys, welcome to video 46, extracting river terrace locations using locate features along route. So in the last video we got started making a geomorphic map of the Middlebury Gorge, and as part of that we mapped a bunch of river terraces. And one of the things we want to do is compare the elevation of those river terraces versus their distance downstream. So to do this, we're going to use a tool called Locate Features Along Route. So in this video, I'll first give you an introduction to the problem and an introduction to the tools that we're going to use. And those tools are, first we're going to create a route from a line, then we're going to use the Locate Features Along Route tool to extract the distances along that line. Then we'll use zonal statistics to extract the actual elevations of the terraces. And then we'll use Excel to plot the terrace data. So just to set the stage, here's an example of our problem. This is a figure from Gran et al. 2013, and it shows a river profile that we've already extracted, and then each dot represents the elevation of a river terrace that was mapped above the modern river channel. And so by looking at the pattern of these river terraces in relation to what they're calling the upland surface or the glacial surface, you can start to reconstruct the history of river incision and figure out how the shape of the river channel changed over time. So in any event, to make this figure, we need to plot terrace elevation versus distance downstream, okay? So we've mapped our terraces, now we need to extract the elevation and the distance downstream. So if you think about this in map view, this basically amounts to asking, if I start counting from 0 at the top of the channel and I measure distance down the river channel, how many kilometers down the channel is this terrace? Maybe it's 1 kilometer. Maybe this next terrace is 3 kilometers. Maybe this one's at 4 kilometers, and so on down to 30, 40, etc. Obviously this would take a long time to do manually. So we're looking for a way in ArcMap to basically extract the distance along a line at which some point would intersect that line. So here's our workflow for how we're going to do this. First, we're going to convert our terrace polygons into points. Then we're going to use the Create Route tool to convert a line into a route. And once it's designated as a route, ArcMap will be able to easily compute distances along it. Then once we've got a route, we're going to use the Locate Features Along Route tool to extract the downstream distance. So what this tool does, it takes points that are spread out around the line and projects them along the shortest distance to the line, okay? And then finds where that projected line intersects and measures the distance downstream to where the point would intersect the line. Okay, and then it's going to output that to a table. So that's how we'll get downstream distance, and then we'll use zonal statistics tool to export the mean elevation of each terrace. Now please note, we're using this tool in the context of extracting downstream distance along a river. This same tool works really well, for example, telling how far down a road a bunch of houses are, or how far along a pipeline a bunch of pumping stations are. So there's a lot of applications where you want to extract this information of kind of distance along a line. Okay, so let's go ahead and get started in ArcMap. Here's our map of the Middlebury River Gorge. And what I did, I continued mapping terraces, and particularly terraces and glacial surfaces after the last video. And then as I showed you, I exported just the terraces and the glacial upland surfaces into this new file called Terraces poly. So if we look at this file, you can see I haven't labeled them all, but I've got glacial surfaces and they're labeled as 1, and then everything else is labeled as 0, and that would be a river terrace. Okay? And so you may have all these labeled as terrace. So in any event, first thing I'm going to do is quickly just display these two different features in different colors. So I'll go to Properties, Symbology, and then I'll go to Categories, and I'll go to Unique Values, And I'll just click Add All Values, or Add Values, and choose those. And you can see it's going to add 49 terraces, 7 glacial upland surfaces. And by the way, I can also label those by changing this value field, so it'll actually show me glacial versus terraces. And what's nice about this is now I'm going to be able to see what's what. So here's my glacial uplands in light blue, and then my river terraces in dark blue. Okay, so now that my terraces are displayed different colors, and I've also added my polyline for the mid-river, we're ready to start this extraction. Now keep in mind, you don't want to start the extraction until you've finished mapping all your terraces. So this would really be the final step you would do after you're done mapping the terraces. But if you are ready to go, the first thing to do is to convert your terraces into points, and that's going to allow us to extract them. So to do that, we'll go to Data Management, Features, and we'll go Feature to Point. So I've got this set up with my terraces polygon as the input, and my output's going to be called terraces points. I'll hit OK. Okay, so have a look. This created all the points, created 1 point for each polygon that I had. If I open the attribute table, one of the features that's great about this is that it records the original FID of that polygon, so we'll be able to match those back up later. Okay, so now we're ready to use the extract locations along a route tool, but the first thing we need to do is create the route. So we'll go to Linear Referencing, Create Route. Okay, and notice my polyline is going to be my input. I don't believe you can do this with a regular line, so you need to use your poly. We chose ID as the route identifier field. Output's going to be saved as midriver_route. We'll measure by length. Now this is really important. The coordinate priority specifies where it should start measuring from. If you choose upper left, it will choose to measure from the upper left part of your line. If we're going to choose actually upper right, because when I extracted my river elevation profile, the downstream distances started at 0 in the upper right. So you should check your downstream distance profile and make sure whatever you choose is consistent with that. In other words, you want to be counting downstream or upstream. In my case, I'm counting downstream. So I'll hit OK. Okay, so that popped up. We've now got our route in orange. And so now we're ready to actually locate the features along the route. So keep in mind what's going to happen. It's going to project the distance from this point to the river, find the closest point on the river, and then it's going to measure the downstream distance to that point along the river. So to do this, I've used my point polygon as my input. My route is the mid-river route file we just made. Going to use the ID as the route identifier. This is really important, the search radius. I'm going to tell it to look for any route that's within 5,000 meters of the point. So if a point is more than 5,000 meters away from the river, it won't be included in this analysis. And you can set this to whatever you want. But in this case, I'm just setting it very large because I want to include all the points, no matter how far away from the river they are. So we'll put our output data table, will be called terrace_dist for distance. Leave these at the defaults, and then I will hit OK. Okay, so the tool finished. I'm going to open the output table here, and sure enough, we've got a nice big table which has the measured distance downstream, called mesh. Then it's got distance, which is actually the distance of the point to the line, and then it's got the original FID recorded here. So what I'm going to do is highlight this row, hold down Shift, so I've got all the rows highlighted. Then I'm going to right-click and hit Copy Selected, and that's going to make sure to copy all the data that I've selected. Then I'm going to come up and right-click and paste that into Excel. So now I've got all my data where I can work with it in Excel. Okay, so the final step, we've extracted the downstream distance of the terraces. Now we need to extract their elevations. To do that, we're going to go back to our old friend Zonal Statistics. That's under Spatial Analyst Tools, Zonal, and then we're going to use Zonal Statistics as table. So to do this, I've got my input feature specified as Terraces polygons. Notice we're not using the points. We're using the polygons that we made originally, and we're going to extract the mean elevation within the polygon, or within the zone. We'll use the ID field to make sure that it extracts, actually take that back, we'll use the FID, and that's going to make sure that it extracts a unique mean for every polygon that we drew. Okay? Then we'll make sure to set the input value raster to the LiDAR image, and we'll output to a table called Terrace Elevations, and make sure to export all the statistics. Hit OK. Okay, so that calculation finished. We've got our table, Terrace Elevations. I'm going to go ahead and right-click, open that table. And here it is. This mean column is going to give us the mean elevation within each of the terrace polygons that we drew. So again, I'm going to hold down Shift, select everything, right-click, copy selected. Going to go over to Excel. I'm going to paste this in right next to the downstream distance data. Now what's great here is that this column, which says original FID, matches up to this column, which is FID. So you can verify that everything's worked out because these should all match, 55, 55, 45, 45. So that looks good. We know that each row is an individual terrace that we had mapped. So the next thing I'm going to do, I'm going to actually copy in my elevation profile of the actual river that we created a couple videos back. So I had that saved in an Excel file where X is downstream distance, Y is elevation. I'm just going to copy that, and I'm going to copy this now right in to this file. Okay, so now I've got my river profile here. I've got my mean terrace elevations in this row, and then I've got my distance downstream in this column. So the last thing we need to do is make a plot. And to do that, I'm going to start by just highlighting these two columns and going Insert, Scatter, and it's going to assume that's the XY. So that looks really good. That's my river profile. Okay. And I'll just add a few labels onto this, and that's elevation in meters. Okay, now I'm going to add on my terraces each as data points. So I'll go to Select Data, Add, and I will choose for my X values, I'm going to choose all the distances downstream. And then for my Y values, I'm going to choose all the terrace elevations. Okay, so now I'd like to add the actual terraces to this plot. And to do that, I want to differentiate terraces from the glacial surfaces. So to do that, I'm going to sort the data. I'm going to hold down Shift and select just these columns, not the downstream distance column. And I'm going to go to Data, Sort. And then I'm going to choose to sort by ID, which is in column E. Okay? I'll hit OK. So notice what this did. All the zeros are together now, and all the ones are down at the bottom here. Okay? So now I'm going to add two additional data sets. I'm going to first add the glacial surfaces, where X is going to be the distance downstream for those particular terraces or surfaces, and Y is going to be their elevation. And now I'll add a second surface type. This is going to be called Terraces, and again, X is going to be downstream distance, but I'm only going to highlight the terraces, and then I'm going to plot that against the elevations. I'll hit OK. Now I'm going to hit OK again, and I'm going to do some formatting on this plot. So to format, I'm going to right click on the line. I'm going to choose Format Data Series, and I'm going to choose Marker Options. I'm going to choose None. I'm only going to display the line. The line's going to be 0.75 width. So there's my line, and I could continue to format this, obviously. I think actually I'd like to make these into something a little more palatable. So this is pretty cool. I can now see all my river terraces, and I can also see my glacial upland surface. If I had drawn in more glacial upland surfaces here, I would be able to draw a continuous glacial surface and see how the terraces had incised down into that. So this will be one of the basic tools that we're going to use in our geomorphic analysis of Middlebury River. This is going to let us start thinking about how old these terraces are and how the river has been incising over time. So in summary, you learned the theory of how to extract river terrace elevations and downstream distances. And then we learned how to extract those downstream distances by creating a route and then using the Locate Feature Along Route tool. And then we used zonal statistics to extract the terrace elevations. And then we used Microsoft Excel to plot the terrace elevations versus their downstream distance. Thanks for listening, and please join us for video number 47. Really, it is extremely hot in my office right now. I'm not kidding.